everyone. Today our topic is how to factorize by taking out the common factors. So you'll probably recall from previous lessons when we talked about prime factorization that prime factorization was when we took a composite number, a number that can be broken down into many different products, and then we broke it down into the product of prime numbers. So for example, I don't know, 12, we broke it down into 3 and 4 because 3 times 4 is 12. And then we broke down 4 into 2 times 2. So at the end we got 3 times 2 times 2, or 2 to the second power times 3. That was prime factorization, right? We broke it down into the products that could make up that number. And since it's prime factorization, we stopped when we got only prime numbers at the end. So today, when we are factorizing or factoring an algebraic expression, we're using that same concept of breaking down our algebraic expression into factors, the numbers that multiply to get to that term or that number. Okay, so be sure that you have this written down in your notes. Factorization or factoring is when we write an algebraic expression as a product, important part, product, the numbers that multiply to get that number or that expression, as opposed to adding or subtracting or dividing. So product, that's multiplication, that'll get its factors. Okay, there are many different ways to factorize, but this year we're mostly going to be studying how to use common factors. Okay, before we go over some examples of how to factor common factors out of an algebraic expression, which will include variables, let's start with something a little easier. Let's start with a numerical expression. So I don't have any variables here. We're just going to do an example without variables first to see how it works. So here I have a numerical expression, meaning I have an expression just made out of numbers. And it's an expression because I see two different terms that are being separated by addition or subtraction. I have 24 plus 18, and I need to factor it. So I'm going to take out their common factor. In order to do that, I need to find the products, right? So I also want to take out the greatest common factor. So I need to figure out the GCF, or the greatest common factor. That will require me to list all the factors. So let me, in the space down below, list all the factors of 24 and 18. 24 is made up 1 and 24, because 1 times 24 will get me to 24. Then I have 2, because 24 is even, so I can split 24 in half. So then 2 times 12 will get me to 24. Next is 3 times 8, that'll work. And then in between is 4 and 6, because 4 times 6 will get me to 24. I know I'm done because after that is just 5, and 5 times 5 is not 24. So I remember I have to work my way in, and I want to pair up my numbers, my factors, so that I make sure I don't miss out on any. Let's go on to 18. So I have 1 and 18. 1 times 18 will get me to 18. Those are my factors. 2 times 9 will get me to 18 as well. I have 3 times 6, which will get me to 18. And what I have left over is just a 4 and a 5 in between. 4 times 5 is 20. 4 times 4 is 16. 5 times 5 is 25. So none of those work. So then that means I'm done. And remember, I need to find my GCF because I need to factor 24 plus 18. So I'm going to take out my GCF, my greatest common factor. They both have 1 in common. Let me go ahead and use a different color. They both have 1 in common, both have 2 in common, both have 3 in common, both have 6 in common, and it looks like that's it. So my GCF is going to be 6. Remember, there are many other ways of finding GCF that we've talked about in the past, but this is just the more traditional way, so that's why I used that method. Remember, you can also use your prime factorization tree to find your GCF. Okay, so if my GCF is 6, I'm going to break down 24 plus 18 into their factors using 6. Okay, so 24 plus 18 could also be 6 times, let's see, for 24, it was 6 times 4. Plus, remember I want to use the 6. 6 times what will get me to 18? 6 times 3 will get me to 18. Okay, so now instead of writing 24 plus 18, I've written the product of 6 times 4, which is 24, plus the product of 6 times 3, which is 18. So I just rewrote it using now their factors and making sure I included not just any of the factors, right? Because 24 could have been written as 2 times 12, for instance. But I wanted to make sure I included their GCF, their greatest common factor, of 6. So now, and notice I put them in parentheses because they go together, I notice that I have a 6 in both of them. So instead of writing it this way, I'm going to rewrite it. They both contain 6 as the greatest common factor. So I'm going to take that 6 out. I'm going to put it in the front because they both share that. And then inside, I'm going to rewrite 4 plus 3. Okay? Because they both share the 4 plus 3. Sorry, they both have 4 and a 3 left over after we take out the 6. That's what's left over. Okay, so this is the new algebraic expression after I factor out the 6. This would really be 6 times 7, which is 42, and that should equal to whatever 24 plus 18 is. Yep, that's 42. They are equal to each other, and they should be because we're rewriting it just in a different way. Okay, so that's basically what factoring out a common factor looks like. You're taking out the factor that they both share, and then whatever factor that was left over, you keep inside the parentheses. All right, let's take a look at an algebraic expression then. So here is example 12 from your book. Factor 15a plus 20b. All right, so again, we had to break it down and try to find the GCF, okay? So let's find the GCF first between 15 and 20. So 15 is 1 times 15, and 2 doesn't go into it because it's not even. 3 and 5. 3 times 5 will get me there. And then I just have a 4 left over because I'm working my way in. 4 times 4 is not 15, so I know I'm done. With 20, I know I have a bit more. 1 times 20 will get me to 20. 2, it's divisible by 2 because it's an even number, so I'll take half of that, which is 10. 2 times 10 is 20. 3 doesn't go into it. 4 does. 4 times 5 is 20. And remember, you can use your calculator if you feel less secure about these types of problems of division. Let's see, they have a 1 in common and they have a 5 in common. So the GCF is 5. Okay, so that means I'm going to rewrite these. So 15 times a, 15a, will instead now be written as 5 times 3, right? 5 times 3 is 15 times a. And then 20 is now written as, 20b is now written as 5 times 4, because 5 times 4 is 20 times b. Okay. So they're the same. 5 times 3 times a is the same as 15a, plus, keep the addition, 5 times 4 times b is basically just 20b. Okay, and then we're going to take out whatever they have in common. They have a 5 in common. And what's left over is 3 times A plus 4 times B. Okay, so that should be your answer. If I wanted to check it, I would actually distribute. So 5 times the quantity of 3A plus 4B. I would multiply everything by 5. So this would be 5 times 3A, which is 15A. And this would be 5 times 4B, which is 20B. Is that the original problem? Yes. So we know that is correct. So basically you are doing the reverse of a distribution problem by taking out the GCF and rewriting the problem with the GCF outside. Let's do one more problem. Go ahead and pause your video. See if you can do this one on your own. All right, so first off, I'm going to list the factors of 24, 40, and 8. 24 is 1 and 24, 2 and 12. Let's see, 3 and 8, 4 and 6, and nothing in between. 40 is 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, and then 6 and 7 don't work. Okay, 8 is 1 and 8, 2 and 4, and 3 doesn't work in between. Okay, so my GCF, let's see, 2 is the same. Do they all have 4? Yes, they all have 4. Do they all have 8? Okay, they all have 8. And I think that's it. So the GCF is 8. All right, so let's rewrite this. 24AX minus 40AY plus 8A. So remember, this is all multiplication in between. So instead of 24AX, remember I want to put that 8 in there. 8 times what will get me to 24? 8 times 3. Okay, and then I just have left over the A and the X. So I'm just going to rewrite that. That's just all multiplication. Minus, keep the minus sign. Let's see, 8 is our GCF. It's got to be in there in every single one. 8 times 5 will get me to 40 times A times Y. So my variables still get written down. Plus, let's see, instead of 8 times A, I'm using my GCF 8 times 1 times A. I really don't need that one, so I can just keep that as just 8 times A, okay? Because 8 times 1, the 1 doesn't really do anything. So they all have an 8, okay? So that means I'm going to take out my 8 later. And let's just double check, because now I have a lot more variables. Do they all share a common variable as a factor? Let's see, this one has an A and an X. This one has an A and a Y, and this one has an A. So what I notice is they all have an A. So I can actually take out an A as a common factor because they all share that. So I'm actually taking out 8A on the outside of my parentheses. And then I'm going to write down what's left over. What's left over, and I can cross out what I already used, so that helps me see what's left over. What I have left over is a 3 and an X, so 3X, minus, so we don't need those parentheses now, 5 times Y, minus 5Y, plus, there's nothing left here, so it's not a 0, because remember later on when we check it, that distribution is going to force this to multiply. So I need to not let that disappear. I need to put a 1 there. Okay, so this will be my final answer. Let's double check to make sure that that works out. And that way you can see what I mean by that 1 being needed. So we're going to check our work here by actually doing that distribution. So everybody's going to multiply by 8. Oh, sorry, 8A. Forgot to write that down. 8A Okay, so 8a times 3x would be 24ax minus 8a times 5y. 8 times 5 is 40. And then I have my ay left over. And then look what happens here. 8a times 1 will just be a normal 8a. So I needed that 1 here so that it can actually reappear. The 8a has something to multiply by. If it was just 0, then anything times 0 would disappear and become 0. So it's very important that I have a value here of 1 so that that 8a can multiply by a number and appear as an 8a at the end. Now, is our original problem 24ax minus 40ay plus 8a? Yes, these two are the same, so it checks out. Okay, so again, we are working in reverse of our distribution problem, and now it's like we're creating a distribution problem. That's what the factoring is. So one is helping you multiply it out, and the other one, because factoring is breaking it down into its factors, it's breaking it down into the multiplication problem. So they're kind of reverses of each other.